Hello everyone, Ivan Ermilov is here and I'm gonna show you how to get started with the BDE platform. Essentially, I'm gonna set up the BDE platform on such an architecture. Basically, I will have three nodes, front-end nodes, node 2 and node 1 in a strong cluster. And I would have another node console for hosting only console key value store for having overlay networks. So, and the front end is exposed to the outside world, so it can be accessed via port 80, and I set up iermilov.org DNS to point to it. So after I have my setup, I want to have hdfs.iermilov.org to point to hdfs file browser and Spark to point to Spark, and essentially the setup should be flexible enough for me to attach a new container, and the Nginx proxy should resolve it to a specific domain name. So let's get started. I'm connected to the front-end node, and this is essentially a 16 gigs RAM machine with 4 cores i7 processor, and it running 3 VMs inside a KVM, and those running Ubuntu 16.04, and the host machine is running Ubuntu 14.04. The first step before you even got started is to make sure that you activated the cgroup enable memory option and swap account equal 1 in your grub config. This will activate swap memory limit support for Docker, and this is necessary for resource allocation when you're running your Docker Windows Farm. Otherwise, if you don't have this, Docker will not know how much memory is allocated, so how much memory is consumed by particular containers on particular nodes, and it can still push more containers there, and then one of the nodes can go swapping. And in my case, because I got VMs, it just become really heavy on the CPU, and my computer basically start hanging up. All right, let's start installing Docker everywhere. For installing Docker, you can refer to our BigDataEurope wiki, which is on a GitHub, and on our BigDataEurope GitHub there is a README Git repository, and inside you can go into wiki, there is a manual installation page. So I'm just gonna go through this setup and install the necessary components here to install Docker Engine in the end. So let's get started. I just would go by instruction here. This works perfectly fine. So first I'm installing Linux headers. Alright, so now that I have installed the additional Linux headers, I believe I have to reboot the machine, so I'm gonna do this now. Alright, so now that I have the necessary Linux headers, I can install the key server and modify the apt sources to have necessary PPA to download Docker from the repository. I'm just gonna paste it here. Now I can run apt-get update. And basically I can install extra headers. Okay, they're already installed on Docker Engine. So after these, Docker should be installed. If you type docker ps, you can see that it's basically there. There is no container running. The next thing is to run the console, but I want to run console on another node, so I would skip for this option. Basically, I want to modify the Docker engine to point to another node and tell it that the console is there. So I would do that straight away, and after that I'm gonna install Docker engine on another node and install console there. Right, let's see. Alright, so what we have here is basically we're telling that the Docker engine should be accessible via TCP on port 2375, and it also should be accessible via a Unix socket, and the cluster store, which is console, is available on this IP address, and it should advertise itself on its own IP address basically. Right. If I restart Docker engine now, it will fail, so I will not do this. I have to open Virtual Manager and start VMs because my machine restarted. So what I can do now is I can connect to console and I will install Docker here. So the thing is, this is Ubuntu 16.04, so I don't have to go through the same procedure as for 14.04. It's a bit different. What I have to do is go to official installation and just grab this line here. So I want to know where the Debian repository is, and then I just edit sources. I will create this Docker list here, paste the line to Docker, oh no, oh right, there is no signatures, so I have to add it, do it again. Alright, now it's good, and after that I do Docker engine, yes, alright, yes, what I forgot to do is to add myself to the Docker group. So Docker and Ivan. So I have to. Alright, so I forgot to add myself to the Docker user group, so I couldn't access the daemon. Now I have the access, so I can start the console store. Here it is. Alright, so we can see that it's running now, and we can check the logs if everything is fine, and it looks fine. We don't touch this machine anymore, and we connect to node. First, let's finish setuping this machine. So it's already here. Just do sudo service docker restart. Alright, and then when you do docker info, what you're gonna see, yeah. So there is a cluster store here, and the cluster advertised, well, it should be the same port as this machine. This looks fine. We can connect to other two nodes and install Docker there now. So we connect to node 1 and do the same thing as for console, essentially, because it's also Ubuntu 16.04. Alright, regarding the Docker default file, which is etc default docker in Ubuntu 14.04. It doesn't work the same way on Ubuntu 16.04. There is an issue on a GitHub for the Docker, and basically you can see that it seems that Docker configuration file is not using etc default docker at all, and the problem is solved by adding an environmental file directive. So I just injected the parameters directly into the Docker service. Now I'm going to restart it. And it works. And if we do info, yeah, it states that the cluster store and advertises here. Alright, that's it for the node 1. Let's do it for the node 2. Alright, so right now we got all 3 nodes, or let's say all 4 nodes configured, and we can proceed to the next step. So we can set up the Docker Swarm. So to set up Docker Swarm, basically we have to run the special Swarm Manager application inside one of the nodes, and other nodes should run Docker Swarm node agent application. They will connect to the manager, and they will be able to distribute the containers. So let's do this. We have to run this command on all of the nodes. So I'm on the node 2, so I'm going to do it here. Alright, so we can see that it runs, and let's see if it's okay. Yes, it looks fine. So we can go to the node 1, do the same thing. So node 1 is ready now, and we finally can set up the front end. Also, I'm going to run one node here. Alright, and the last thing, I have to run a manager. I'm not going to run 2 of them, just going to run one manager on front end node. So it's going to run on port 4000, that's the default one. Alright, so now you can do this, and essentially if you do -8, then it will show you all the agents in the manager, and -h colon 4000 means that I'm connected to Swarm Manager, which exposes port 4000 here, and you can see that it prefixes a container name with front end or node 1, node 2, basically showing where it is running now. So essentially that's it. The swarm is running now, and I can also show you info. And what we can see here, we can see 3 nodes. We can see that the first node got 16 gig of RAM, and the second node got 4 gigs of RAM, and third node got also 4 gigs of RAM. And actually here it's saying, yes, here the total RAM is 24 gigs of RAM, but this is not true because these 2 nodes are VMs inside this node. So when you having VM set up, basically the resource allocation, you shouldn't put the physical node into the same swarm as I did right now. Alright, so that now we have our Docker Swarm cluster running. The next thing is to have the BDE application running on top of it. In particular, we're going to run the Spark, HDFS, and HDFS browser. So let me clone my repository here. And after that, the first thing to do is to run the Nginx proxy. So we will have all the subdomains of ermilov.org routed to particular containers, and I'm just gonna show you how it should be configured in the end. So let's see if this works. I'm just connected to the front end right now, and the Nginx proxy should run on the front end because that's where we can see it from the outside world. And what you can see here is that it's connected to my net, which I created previously using this command, -8 for network. Then you can see that here is a create, and you can list all the networks. So basically, to create an overlay network, I'm just going to create a new one to show you. You can do this, and then it's basically created. You can list it, and I don't need it, so I'm just going to delete this one. All right. So right. The next thing is we're gonna compile or build our Docker images here. I'm not using all of the images from the Docker Hub. I'm not published all of them on the Docker Hub because, well, I prefer to have Nginx configuration and this integrator UI. I prefer to have a simple wrappers for like base images locally, so I can modify them depending on the deployment scenario. So like in integrator UI, you can see that Dockerfile is really small. Basically, I originated from the integrator UI version 0.3.0, and then I just copy custom user interface, and that's it. So I'm gonna build this one, and I'm gonna also build the front end, which is a custom Nginx. Now what I'm gonna do is basically I got these 3 Docker Compose files, stage 1, stage 2, and stage 3. And stage 1, I'm gonna deploy the name node and Spark Master, as well as HFS file system or file browser, which is not necessarily has to be deployed together with 2 of those, but it's quite time consuming, so I deploy it on stage 1. And after that, on stage 2, I'm gonna deploy 1 data node for HDFS and 1 Spark worker, and I'm gonna deploy integrator user interface, which basically is a frame application which unite the Spark, Hadoop, and file browser interfaces into one. And in the end, I'm gonna deploy the stage 3, which is essentially only 1 service. And as you can see it here, there is a special config with a virtual host environmental variable, and this means that all of these 4 domain names gonna resolve to this container. So let me fire it up against our swarm. So docker stage 1 -d. Alright, so now we have name node, Spark Master, and HDFS file browser pulled. It took some time. Let me check if they run fine. Yes, they all run on the front end, and I'm just gonna take a look at the logs of Spark Master to see. Yes, it's selected and it's alive. So now I can start this stage 2, which gonna start Spark worker, 1 data node, and integrator UI. I tried to create data node, Spark worker, and integrator UI, and it complains that integrator UI is not here, so basically I have to build it on this node. Alright, so now we have integrator UI running, and one worker, one data node, Spark master, name node, and HDFS file browser, and there is also Nginx proxy. So we just have to run the last stage 3, and after that I can browse to the applications itself from my web browser and show you how it works all together. And now all of the services are running on our cluster. I just check one more time to see if it's there. And now I'm gonna navigate to separate services. So I'm gonna show you name node. Here is a name node I deployed, and if you go to data nodes, you can see that there is one data node available. I will go to Spark. Here is a Spark master, Spark 2.00, and there is one worker. And there is also file browser. You can see I'm not gonna log in. I'm gonna switch to the integrated user interface, where I can see all 3 interfaces in one. So it's exposed here. So if I click Hadoop now, I can see Hadoop. If I click Spark, I can see Spark. If I click the file browser here, I can go to Hue. And it's the first time I run it, so I can create account. Don't want to save. I just go to file browser and I'm gonna upload something there. See, I got a FOF RDF here. Alright, so that's basically it. I will remove this file right now. Yeah, move to trash. Yes. Alright, and that's the initial setup of the BigDataEurope platform. Thank you for watching, and in the next screencast I'm gonna show you how to run this simple Spark application, and we're gonna have a different screencast for the different components like Hive and other storage solutions, etc., etc. So subscribe to our YouTube channel and keep updated. Thank you.